Okay, so 7-4 is all about using the z-test for proportions. So the 7-2, you did, all the questions dealt with the mean. Mean, HO was something to do with the mean. Greater than, less than, or is a certain amount. With all of these type of questions, they will all be talking about proportion, usually in the form of a percent. Okay, so your HO and HA will all deal with the percentage. What's special about these is that you have to do the test to make sure you can even do it at all. So just like with the t-score, you have to say the n is less than 30, it's normally distributed, and we don't, the population standard deviation is unknown. With proportions, you have to say that the n times p is bigger than or equal to 5, and the n times q is bigger than or equal to 5. And if it's not, and you have to state that you have to state it, you have to show it. If it's not, then you can't use the z-score, you can't do the hypothesis test. But if it says yes, NP is bigger than 5, NQ is bigger than 5, then you can go on and continue the test. So when you're writing up these assignments, you have to make sure to state what the N times P is and the N times Q is. I am not on a camera. There we go. Okay, so I'm going to show this one, and then we'll work at the bottom one together. So a research center claims more than 25% of the U.S. adults have used the cellular phone to access the internet. I think that's actually going to would be higher now these days. In random sample of 125 adults, 32% say that they have used a cellular phone to access the internet. And at an alpha of 0.05, is there enough evidence to support the researcher's claim? So the first thing you have to do is obviously identify your N, your P, and your Q. Your N was 125, that's your sample size. Your P was the percentage of the percentage of the claim, so 0.25. The percentage of the people is the sample result. So you keep those separate. We needed 25% to say of 125, and that is bigger than 5. And then 75% of 125 is 93, so that's bigger than 5 as well. And then our HO and our HA, well, it comes off of our question. What is he saying? Well, he said that the more than 25%, that's greater than 0.25. So that's our claim, and therefore our HO is less than or equal to 0.25. Our alpha is 0.05. So if you looked up the alpha on the chart or used your technology, menu 653, you would find 1.645. Okay. So the amount of shading is shading to the left because the HA was greater than, and that is 0.005, which corresponds to 1.645. So the rejection zone is P is bigger than 1.645. Okay. A Z is bigger than 1.645. Then we would use the same formula we've been doing, X bar minus mean over standard deviation. And then here's where things get a little different. So you do the P hat minus the P, or it could be written as P hat minus the mu of P hat. You don't see this very often, but they mean the same thing. So P hat minus P. So the P hat is the samples percentage. The P without a hat on it is the population percentage. Okay, and then over the square root of the population percentage times the population complement divided by n. So in our case, it's 0.32 minus 0.325 over the square root of 0.25 times 0.275 divided by 125. And that whole part on the bottom has to be under the square root. So make sure that the fraction is all under that square root. That 125 has to be part of that square root part. And so that Z is 1.81. And as you can see, I pointed to it. Where is that going to be? Well, that would be in the rejection line. So we would reject the HO and accept we would support, I should say, the HA, because if we reject the HO, then that makes the HA true. Okay, so let's look at the second one. We'll do that one together all the way through. All right, so these are the same basic, it's basically the same 6 steps after step 1. So step 2, 3, 4, 5, all of those steps are basically the same. And you can use the alpha versus the p-value. So on the first one, I did the alpha, I did the test statistic against the critical value. On this one, we'll do the p-value versus the alpha. Okay? Because it really doesn't matter. As long as it's a z-score test, you can use either one. T-score, you have to use critical value versus the test statistic, which is probably why I prefer always doing that, unless they tell me I have to do it otherwise, because then it's consistency. I'm doing the same process every time, but I want to make sure you guys see both ways. Okay, so this question, it says that the researcher claims that 30% of the people have not purchased whatever. Okay, so that is talking about P is not equal to 0.30. And not equal to, and that's our claim, gives us our HA. So our HO, which I always put on top of it for consistency, is 0.30. Also, that helps me to remember that I always am testing the HO. Okay, and our P here is 0.3, which means our Q is 1 minus 0.3 or 0.7. Okay, and then they said that you have a random sample of 250, which is our N. So we need to do our real quick check. N times P, which is 250 times 0.3. And we need to know, is that bigger than 5? So I don't have that written on my paper, so I'm going to go ahead and do it on math. All these stupid cords all over the place. So 250 times 0.3, we get 75, which is definitely bigger. And 250 times 0.7, which is 175, which is definitely bigger. So we're good on our 2 checks. Okay. And then you want to figure out, well, what is the HO and HA? We did that. So this was step 1. This is step 2. Step 3, we identify the alpha. Alpha is 0.10. We identify our Z. It's talking about the Z critical and rejection zone. You can actually say that as being identify the p-value if you wanted to. So we're going to first find our Z. So x bar minus, I'm sorry, p hat, which is 0.30, no, 0.36, that's their p hat. 0.36 minus 0.30 over square root of 0.3 times 0.7 divided by 250. Square root fraction, 0.3 times 0.7 over 250. So that's what it would look like in your calculator, if that's clear enough. So 2.07 Did I type that in right? 630. Yeah, I had it wrong on my original paper. Dyslexia, sticking the ugly head again. Okay, so now we're going to look up the 2.07 in your Z chart. Can somebody quickly look that up if you have it available? Because mine is hiding. I think I might be able to get to it fast. I am so sorry. I can't find my stupid chart. Okay. 2.0. 0.9808. Okay. I'm sorry. I forgot something. Is this a one-tailed or two-tailed? Two-tailed. So you somewhere should have here showing the two-tailed. And remember that 0.10 has been divided into half. Okay. So if it's 2.07, you said that the ZP of Z is less than 2.07 was how much? 0.9?
0.9808.
08. So this is all the way out to wherever it lands. That's the shading all the way up to that. So we actually have to do 1 minus that to figure out what our p-value actually is. Point 0.0192. And then we would compare that number to the 0.05. Okay. This is why one reason I also like using the ZT critical to the and looking up the alpha, because if this part confuses you or you can't remember how to find the p-value, if you at least look up the alpha using your technology or your chart, then you can say, okay, well, these numbers here are alpha. Menu 6.5, and we are looking up Z chart, so it's 3.05 is negative 1.645, which means this is 1.645. So if you kind of get stuck with the p-value thing and that's not working for you, you can always go back and look up your alpha, and that will tell you these two spots where the two coloring is. Just be careful when it's a two-tailed that you divide the alpha by 2. Otherwise, you're going to get the left side instead of not getting both sides. Okay, now if we did it, we compare the two, where would 2.07 be numerically on a number line?
Over.
Yeah, somewhere around here, right? So in that case, do you reject or not reject? Reject. So if we reject the HO, that means the HO is false. So what does that tell us about the claim? HO, we reject that, making it false, which makes this true, which makes the claim we can support. And I know that's not it's kind of like all over the place so that you can see it. If we had done the p-value, p is less than alpha, and then you just have to remember that little chart that I gave you. Quite honestly, this is one of the reasons why I always go to the T chart, the alpha and the Z, because it is much easier to think of the number line here than trying to remember that little chart and that little rule about p-value or alpha. But if you remember that the p-value is relates to the point where you're pointing, And this is always the do not reject. So if it's in here, that's where we want our p-value to land. So in that case, it kind of helps you to remember what to do with the p-value. If p is bigger than the alpha, or in this case, between the alphas, then you would not reject. If p is inside the alphas, then you would reject. So the other thing to do it is 0.10. If we were doing the, that would end up being 90%. So anyways, in this case, I think I would just stick with the the critical value versus the test statistic. Z sub alpha versus Z, which is based on the sample. Okay, that's basically it. That's all of the parts for that. We'll do this one today, and you'll finish up 7.3 and work on 7.4 tomorrow and Friday. And then on Monday and Tuesday, what we'll do, let's see, next week is not the last week of the 6 weeks, right? We have one more week after that. Okay, so good, because that's what I was afraid we were going to run into. So Monday and Tuesday, we'll do 7-5. We might stretch it into Wednesday to give you guys a little bit extra time. We'll review this whole section really good on Thursday and Friday, and then Tuesday of next week we'll take the test, or maybe next Friday we'll take the test and give you guys that kind of time, because this takes a bit of time. Each one of these questions takes time. So, and I'll have the other test. That'll give us our 2 tests. We'll be good. So, okay. All right, now I got to stop this thing.